All right, so starting us off, problem number 19. Inscribed angle, we want to identify the following features. First one is an inscribed angle. An inscribed angle is an angle that has its vertex on the circle. So this right here has its vertex on the circle. That would be an example of an inscribed angle. So we could say angle CDG. That is not the only one in this picture. Instead of going from C to D to G, we could have done C to D to A. That still has its vertex on the circle, meeting the requirements to be an inscribed angle. So angle CDA. Or could have gone the other direction and done GDA. This angle right here still has its vertex on the circle. All right. Central angles. Central angles have their vertex at the center of the circle. So this angle right here, angle DAF, would be a central angle. Or there's another angle shown there that is a central angle. We could look at this angle right here, angle HAD. DAE, technically that's a central angle, but that's also just a straight angle. DAE would be this, right here. Oh, sorry, DAE. I heard HAE. DAE would be this. You could do DAE. That would be the same angle as DAF. So yes, that would also work. I would count that as correct. Tangents. Tangents are lines that touch the circle in exactly one point. There's only two lines in this picture. There's this line here. How many places does that touch the circle at? Two. One right here and one right here. There's another line in the picture, and that's this one right here. How do I know it's a line and not a segment? Because it's got the arrows on the ends, showing me that it goes on forever. This line right here touches the circle in how many spots? One. Where is that one place? H, right here. So that is my tangent line. We could label that as line HB. Make sure you use line notation and not segment notation because this is a line, so it gets a dash with the arrows over the top. We could call that same line HJ. That's another point that's on the line. Or you can call that line JB. All three of those ways are ways to name the exact same line. That point where the line touches the circle is called the point of tangency. So our point of tangency here would be H. Then we have a secant. We've actually already seen the secant. A tangent is a line that touches my circle in exactly one place. A secant goes all the way through the circle, so it touches it in two spots. That's what we saw from this line right here. That touches my circle at C, and it touches the circle at D. So that would be a secant line. We can call that secant line BD. We could call that secant line CD. Those are the only options, BD or CD.
So the thing that separates the tangent line from the secant line is the tangent line touches the circle at 1 point, while the secant line touches the circle at 2 points.
Yep. Yep. And then the last thing we have is a chord. A chord is kind of like a secant, except a secant is a line that continues on forever in both directions. So it goes all the way through the circle. A chord stops at the edges of the circle. So a chord is a segment, not a line. This right here, from C to D, stopping at C and stopping at D, is an example of a chord. There's at least one more chord up there. Can you guys find another chord? HF. That one is a very special chord. Does anybody know what's special about HF? Goes through the center, so it's a diameter, but that is also a chord. A diameter is a special kind of chord. So HF. Make sure you're using segment notation here and not line notation. If you use line notation, then you're saying it's a secant, not a chord. I see another chord in the picture up here. DG. This one right here. All right. What else would you guys like to see from the review? 20? Absolutely. And then I thought I heard another one. You also said 20. Okay, so it was the same thing twice. Number 20, we'll do part A. It says write each degree measure in radians. If we want to go from degrees to radians, we multiply by pi over 180, and then we reduce. So 60 degrees, we're going to take 60 degrees times pi over 180. The 60 will only multiply with my numerator. So I would have 60 pi over 180. And now I have to reduce this down. Both of those numbers end in a 0, which means I know immediately that what can go into both of them? 10 can go into both of them. Let's divide them both by 10. That'll reduce it down quite a bit. 60 divided by 10 would give me what? 6. So that'd be 6 pi over what? 18. Is there anything that you know of that goes into both 6 and 18? 6 goes into both. Thank you. 6 pi divided by 6 would give me what? 1 pi. Yep. So I have pi in my numerator. What is 18 divided by 6? 3. So pi over 3 would be 60 degrees written in radians. You follow that exact same process for part B. You're going to times it by pi over 180 first. You take the 275 times the pi, so it ends up in your numerator. So you'd have 275 pi over 180, and then you go about the process of reducing that fraction down. What else would you guys like to see?
31.
31, absolutely. Do 22 after that? So 31 and then 22. Sorry, yeah, 22. 31. Given a regular octagon with radius of 5 inches, that's important. Draw the radius and then find the perimeter and area. So first thing we're going to do is draw in that radius. Radius goes from the center to a corner. So that is what would be 5 inches. We're going to find the area first and the perimeter second because the area is easier for us to find here. To find the area, I'm going to draw in another radius, which would also be 5 inches. And then I'm going to need the measurement of the central angle. How would I find the measurement of the central angle? Yes. We're going to do 360 divided by the number of sides that we have. How many sides are there on an octagon? 8. So I have 360 divided by 8, which comes out to be 45. So my central angle is 45 degrees there. To calculate the area, area is 1/2 AB times the sine of angle C times the number of sides that we have. Or you can do 1/2 apothem times perimeter. Those are both ways to find the area of a regular polygon. Which one makes the most sense for us to use right now? Do we know the length of the apothem? No. Do we know the perimeter? No. This formula over here, this part of it right here, finds the area of this triangle. And then we multiply that by the number of sides, because that's how many triangles I could make if I drew in all of the radii of this circle. I could make 8 total congruent triangles, just like that bottom one. A and B are sides of the triangle. C is the measure of the central angle. It's the angle in between my two sides. So for this particular problem, I feel like this formula would be the easier one to use since I don't know the apothem or the perimeter yet. You could use 1/2 apothem times perimeter, but you're going to have to calculate both the apothem and the perimeter first using SOHCAHTOA. We're going to have to use SOHCAHTOA to find the perimeter in a minute anyway, but you would need to do SOHCAHTOA a second time to find the apothem. All right, so we have 1/2 AB. What are we going to put in for A and for B? 5. So 5 times 5, you have to have 1 for A and 1 for B. One of the things I saw when I was grading this test where you guys had to do problems like this is we were putting the 5 in only once. A and B are each sides and they are the same size. Times the sine of angle C, which we said was how much? 45 degrees. Times the number of sides. So we're going to multiply this all by what? Multiply it all by 8. And what do we get for our area? 70 point, I didn't hear the end. 71, I got 711, yes. That would be inches squared, because they gave us the radii in terms of inches. So 70.711 inches.
Doesn't matter if you just leave it at 70.71.
Depends on the directions on the test. You got to pay attention to the directions there. If the directions say exactly how many places you should round to, then you should do whatever the directions say. If not, 2 decimal places would be okay. All right, so that's our apothem. We still need to find the perimeter. Sorry, that's not our apothem, that's our area. We still need to find the perimeter. So to find the perimeter, I need the side length. I'm going to come back up to my picture up here and I'm going to draw in the apothem. That would come down like this. It would split my little blue triangle into 2 smaller congruent triangles. And I'm actually going to redraw that right down here so that it's a little bit easier for me to see. All right, so here's that same triangle drawn a little bit larger. This is the apothem. This is my radius of 5 inches. This is half the side of the octagon. And this angle up here is not my central angle, but it's very closely related to it. What is this? Half the central angle. So we would do 45 degrees divided by 2, which is 22.5. All right, so now we need to do SOHCAHTOA. Which means we need to label up our sides. The 5 inches is which side? Hypotenuse. The apothem is which side? Adjacent, yes. Apothem and adjacent. And that means down here, the half side of my octagon, this is the opposite side of my triangle. That's one of the things I'm trying to find, and the only number I have to work with other than the angle is this 5-inch hypotenuse. Which of these 3 in SOHCAHTOA lets me use the opposite and the hypotenuse? Sine. Tangent uses opposite, but it also uses adjacent, which would be my apothem, and I don't know how big that is. So we have sine of my angle, 22.5 degrees, equals opposite over hypotenuse. How big is my opposite side, or do we know? We don't know. This is the half side over the hypotenuse, which is 5. What do I need to do if I'm going to solve that now? We're going to multiply by 5 on both sides so that we can cancel out that denominator. So let's grab our calculators. We're going to do 5 times the sine of 22.5. What do we get? 1.913 is equal to the half side. What do I need to do if I want the whole side now? Multiply that by 2. That's going to cancel this out. My denominator of 2 cancels out with the other 2. So now I have a whole side. And a whole side is equal to 3.826 for the side. So if this right here is 3.826, what would I do to calculate the perimeter? Times it by 8. Perimeter is number of sides times the length of each side, so that would be 8 times 3.826, which gives us a perimeter of what? 30.614. I got 608.
Oh.
It probably just depends on how you rounded it. If you wrote 30.614 on your test, I would not count that as incorrect, especially if you showed all of your work. 30.608 inches. All right. Now we're going to go backwards to number 22. So back towards the beginning of this section, excuse me. Number 22, given the circle, answer the following questions. We want to find x, the measure of arc BEC, and the measure of arc DA. So there's a couple things that I know just from looking at this picture. If this angle right here is 99 degrees, how big is this arc right here? 99 degrees. If this angle is 57 degrees, how big is this arc? 57. if this arc, or sorry, if this angle is 56 degrees, how big is the arc? 56 degrees. How many arcs do we not know? 2 arcs that we don't know. This line segment right here is kind of interesting to me. DB. Why is that one standing out to me?
Because it's straight.
It's straight. It goes right through the center. It's a diameter. Yes, this is a diameter. What do diameters do to circles? They split them in half. So the arc from D all the way around to B would be how big? 180. So what could I do to find this arc right here? Yes, let's do that. 180 minus 99 would give us what? 81. So this arc is 81 degrees. That means this angle right here is 81 degrees. They wanted me to find x. Now I only have one arc that I don't know, correct? This is the only arc that I don't know. I know that if I add up all the arcs all the way around the circle, it should add up to how much? 360. So let's add up all of the arcs all the way around. So I have 2x minus 7 plus 81 plus 99 plus 57 plus 56, and that all adds up to 360. So now we need to combine our like terms together. I have a negative 7 plus 81 plus 99 plus 57 plus 56. What do we get when we add those all together? $286. So 2x plus 286 equals 360. And then we subtract 286 from both sides. I get that 2x equals what? 2x equals 74. And then we divide both sides by 2. And what do we get? 37. X equals 37. So there's my first answer. All right. Next, we want arc BEC. Well, B is right here. E means I have to go this way. And C takes me all the way around to over here. That's almost the whole circle. That's the whole circle except for what?
99.
Except for 99. So how would I find that arc?
Try 99 from 360.
Yes, 360 minus 99. And what does that give me?
261.
261 degrees. All right. And then we have arc DA. Well, arc DA, here's D. Take that all the way around over here to A. How could I calculate that arc size? $37 plus 56, not 37, but you're close. 37 is just X, it's not that arc. 37 plus what? No, remember, 37 is X. We could do it like that, but we want just DA. We already know what X is. What you're suggesting would have me find X. We know what X is. What do I want to do with that X? Substitute it in. We're going to take it, substitute it in the place of X, so then we'll multiply 2 times the 37 minus 7. So we'd have 2x minus 7 plus 56. And then we substitute in for x. So 2 times 37 minus 7 plus 56. All of this right here to get this answer. What do we get? 123. All right, what else would you guys like to see? Yes. 24? Absolutely, we can do 24. So the key to problem number 24 is remembering what we learned about tangent lines. 24 says find the value of x, assuming lines that appear to be tangent are tangent. So this top line right here appears to be tangent. It's touching my circle in exactly one spot here. So that makes this a tangent. And this bottom line, I have the same thing happening here. It touches my circle in exactly one point, so that makes this also a tangent. And those two tangents come together and touch each other right here at this common endpoint. When we have two tangents, they are congruent. Yes, when they have a common endpoint and they're both tangent, they are congruent. And what do we do with things that are congruent? Set them equal. So 2x minus 5 equals x plus 6. So now we solve this for x. We get our x's to the same side first, so I'm minus x from both sides. That would give me x minus 5 equals 6. Then we add 5 to both sides. And that gives us x equals what? X equals 11. I have time for 3 or 4 more questions, depending on how long they are. What else would we like to see? 25? Absolutely. After that, 32. 25, then 32. 25. Find the measure of angle SXW. SXW. This is the angle that we want to find the size of. Well, if I could figure out how big this arc is right here, I know that the angle is half of that arc. Measure of angle SXW is half the measure of arc SVW. The arc is half the angle. Okay, so let's see if I can figure out how big that arc is. One thing that I notice is this 36 degrees, and that's this angle right here. So I can use that to figure out this arc over here. If I know the angle is 36 degrees, what do I do to find the arc?
Multiply by 2.
This would be 36 degrees times 2, so that would make it 72 degrees right here. And then if I could just find this arc right here, that would be the only other arc that I need on that circle so that I can find the orange one. This is the angle that intercepts that arc. It's 64 degrees. So what would I do to find that arc?
Multiply by 64.
Yep. Multiply what by 64?
Oh, 2.
Yes. We're going to do 2 times 64 degrees, which gives us 128 degrees. Now do I have enough to be able to figure out how big that orange arc is? Yes. We're going to do 360 minus, and then we need to combine that 128 and 72 together. So that would be 360 minus what? 200, which gives me 160. So this arc up here is 160. So the measure of angle SXW is equal to 1/2 of 160. What is half of 160? 80. So the measure of angle SXW is 80 degrees. All right. 32 was the next one I was asked for. So let's flip forward to number 32. (32) says, given the diagonals of a rhombus are 72 inches and 96 inches, find the perimeter and area of the rhombus. So this right here would be my 72 inches, and this right here would be my 96 inches. What happens right in the middle where they cross each other? They intersect. Specifically how? They make a right angle with each other. What else are they doing to each other?
They cut each other in half.
They cut each other in half. So if this big long one right here is 96 inches, how big is each half? 48. So this is 48 inches right here. This is 48 inches right here. And if the shorter diagonal is 72 inches, how big is each half? 36. I have 36 inches and 36 inches.
Thank you so much. Have a good day.
Right. Thank you. Congratulations on graduation. All right, we need to find the perimeter and the area. Let's find the area first. Does anybody have the area formula for a rhombus written down? Yes. Close. It's not diameter, it's diagonal. But yes, other than that, you're 100% correct. Thank you. We have 1/2 diagonal 1, I'm sorry, Desire, times diagonal 2. So 1/2 times what? 72 times 96. Let's grab our calculators and pop that in. $3,456. Would we put units with that? Inches squared, yes. 3, 4, 5, 6, yes. 3,456 inches squared. Okay, that's my area. Now we also want the perimeter. The perimeter is the distance all the way around the outside, right? What do we know about all the sides on a rhombus, though? They're equal. So this side over here is the same size as this side here, is the same size as this side here, is the same size as this side here. So if I can find one of them, then I can find all four, right? So let's look carefully at just one of these little triangles inside here, because that's what kind of triangle? That's a right triangle. And we want to know one of the sides on a right triangle. We know the other two, so what could I use? Pythagorean theorem. A squared plus b squared equals c squared. What would have to go in for A and B? 36 and 48. 36 squared plus 48 squared equals C squared. That is my hypotenuse because it is opposite from the right angle. What is 36 squared? 1,296 plus what's 48 squared? 2304, 2,304. Then we have to add those two together. What do we get when we add those up? 3,600 equals C squared. Now what? Square root. If you do it to one side, you got to do it to the other side. Squared and square root cancel out on C. What is the square root of 3,600? 60 is equal to C. So this side over here is 60. That means this side is also 60. Another 60 and 60. So what do I do to calculate my perimeter? Times it by 4. 4 times 60 would give us what? 240. And that would just be inches, not inches squared. All right. I have enough time for one or two more, depending on how long they are. Yes. Number 40? Absolutely, we can do number 40. All right, so we're on the very back of the packet now. This is the pyramid question. Find the volume of the square pyramid. How do you find the volume for any pyramid?
Length times width times height. Well,
No.
it depends on the
I want a pyramid.
base.
Look up the formula. What is the formula for a pyramid for volume?
Oh, base area of the base times the height.
Super close. Very, very close. It's not just area of the base times the height, although those are two components of it. There's one other piece there. Again, we want pyramid. There we go. 1/3 area of the base times the height. And I'm really proud of you guys for saying area of the base and not base. Because when people say base, they just grab one number and pop it in. Area of the base is always something that you have to calculate. What shape is the base? A square. So this becomes 1/3 times the area of a square times the height. How do we calculate the area of a square? Side squared. So 1/3 times side squared times the height. How big are the sides of the square? 11. So 1/3 times 11 squared times what is the height of the pyramid? 10. So 1/3 times 11 squared times 10 gives us what? 403.333, or you could do 3 repeating. That would be kilometers cubed. All right, we only have about 3 minutes left, which is not really enough time for me to go through any of these problems, so I apologize that we have to stop right here. Monday and Tuesday, you guys have the entire class period to work on your cheat sheet for the final exam. I am also more than happy to continue answering questions for you on Monday and Tuesday, but I'm not going to lead anything from up at the front. I'm not going to make any more recordings for the remainder of the class, for the remainder of the year. I will happily answer individual questions, so you can come up and ask me, or I can come to you and answer your questions on Monday and Tuesday. You have both days to work on your cheat sheet. You will be turning it in on Tuesday at the end of class, so it is really important that you guys work on it both of those days. Also, as a reminder, you will be turning in the final exam review packet itself the day of your exam, which is next Wednesday, the 21st. Next Wednesday is your exam in here.